Assalamualaikum warahmatullahi wabarakatuh. To my respective panel, I are Dr. Safwan bin Wan Ahmad and I are Awang bin Taib. So my name is Muhammad Rafiq Zikri bin Syed. ID number AA17155. My supervisor is Dr. Sharifah Maszura BT Syed Mohsin. So today I'm going to present my final year project. The topic is the performance of concrete using Kenaf core as partially cement replacement. So for the introduction, concrete is the most used building material since it can increase stability and flexibility in designing building structures. One of the main materials for making concrete is cement. The most common used cement today is the Portland cement. In this study, Kenaf core is used as partial replacement of cement in concrete. Kenaf is a very useful plant that can be used in various industries and it is a tough plant that can grow in the temperature that hot and humid. It's why Kenaf were choose to combine with other composite materials such as concrete. For the problem statement, the most crucial problem of current cement are highly polluting and use a lot of energy to produce it. Cement production release carbon dioxide which can contribute to the global warming. There are a huge amount of persistent organic pollutants which are very toxic substances that will be released. This can wreak our havoc in our tissues, damaging nervous system and other critical problems such as cancers. So for the objective of the study, first is to investigate mechanical properties on compressive strength of concrete with different percentage of Kenaf core. Number two is to investigate mechanical properties on flexural strength of concrete with different percentage of Kenaf core. And number three is to investigate the physical properties of water absorption of the concrete with Kenaf core, especially cement. Okay, for the scope of study, the scope in this investigation is to develop the concrete with Kenaf core as partially cement replacement. Kenaf core with 0, 5, 10, 15 and 20% will be used to replace the percentage of volume of the cement. 45 sample of concrete cube size 100 times 100 times 100 mm and 30 sample of concrete prism size 100 times 500 times 100 mm. The result testing obtained from the alternative sample will be compared with the control concrete cube and prism. There are three testing that will be conducted: the compressive strength test, the flexural strength test, and the water absorption strength test. The testing for compressive strength and flexural strength will be conducted at 7 and 28 days, while the water absorption test will be conducted at 28 days. So for the significance of study, firstly is to spread the knowledge about using Kenaf core into a possible material that can benefit people and reduce environmental pollutant. Next is Kenaf core could become the alternate way to partially replace the cement that could be expensive in the future. So for the literature review, firstly, from the research topic, a review on emission analysis in cement industry, renewable and sustainable energy reviews by Ali et al. From 2011. So for the finding is cement production use 12 to 15% of the industrial total energy use worldwide and cause CO2 emission across the planet, which cause to global warming. Number two, from the strength and durability of concrete containing quarry dust as partially replaced of cement by Ma'ruf A et al. 2017. And the finding is lightweight structural concrete were recommended to be used up to 20% quarry dust as cement replacement. And number three is cement replacement by fly ash in concrete by R.B. Padier et al. 2016, which conclude that concrete with more fly ash as partial cement replacement decrease the compressive strength and not be safe for different concrete mix if the replacement is above 40%. For the number four, from the research topic of a study on canal fiber reinforced concrete block with quarry dust as fine aggregate replacement by Azrizal MF et al. 2015. The finding is canal fiber in concrete can partially replace sand and quarry dust. 1.5% of canal fiber show the lowest density of the canal fiber reinforced concrete block, which good for practice. Number five, from the research topic of Kenaf fibrous concrete mechanical properties with different fiber volume fraction from Maszura et al. 2018, which said that Kenaf is a very useful plant that can be used in various industries such as medicine, paper production, and composite materials, whether the stems and seeds. And lastly, from the effect of different concentration of sodium hydroxide on Kenaf sandwich structure by M. Aziz et al. 2017 that state the mechanical testing shows the better result of NaOH with higher concentration used. Mechanical properties with higher concentration such as 9% of NaOH sometimes show slightly decrease, perhaps because it burned the fiber. So let's go to the methodology. Firstly is design, next is material preparation, and then sample preparation, then testing, that will be after that result, then conclusion, and lastly is report. So for the material preparation, material was for the concrete was taken from concrete lab and need to be sieved to get the size needed. But for the cement, just take directly without need to sieve. And then after that, all the material will weigh according to the amount to be used and then placed according to the batch of casting to easier the process of casting. For the Kenaf core, uh, there are a picture of Kenaf core before processing, and the Kenaf core need to process with the sodium hydroxide that will be soaked for 24 hours, and after that will be filter it and air dry before the casting. So for the specimen, so for the type of concrete, there are two type of concrete, which is concrete cube and concrete prism. The concrete dimension for concrete cube is 100 mm meter cube, and for the concrete prism will be 100 times 100 times 15 500 mm. So for the number of sample, there are 45 number of sample for concrete cube and 30 number of sample for concrete prism. So now let's go to the result and discussion. So for the percentage of concrete with Kenaf core are different by its percentage placement, which is 15, 10, 5, 10, 15, and 20% of Kenaf core. All data from compressive strength, flexural strength, and water exertion rate with water curing will be compared with the standard control. According according to the According to the above result, mostly the compressive strength of the concrete cube dropped when the partial replacement of cement with Kenaf core was added. The compressive strength The compressive strength could be affected by the porosity and density of the concrete cube. The sample with higher porosity and lower density could make the strength lower. For 7 days, the compressive strength of control sample is 24.83 Newton meter squared, meanwhile the highest compressive strength result for the concrete with Kenaf core are 10.489 Newton millimeter squared. The concrete with 20% of Kenaf core was the lowest compressive strength for 7 days of water curing. Then for 28 days, the compressive strength of control sample is 35.032 Newton millimeter squared. Meanwhile, the compressive strength result for 5% are 18.801 Newton millimeter squared. For 20%, it showed the lowest result of compressive strength. All the ratio have higher compressive strength at 28 days of curing because the sample have gained its maximum strength. The highest compressive strength occur at 28 days is the concrete cube with 0% Kenaf core, that is 35.302 Newton millimeter squared. Same goes to water curing process for 7 days with the compressive strength of 24.83 millimeter squared for the 0% of Kenaf core. So here the picture of the concrete cube with 0% of Kenaf core and the concrete cube with 5% of Kenaf core. So we can see here that the concrete cube with 5% of Kenaf core are heavily damaged after the compressive strength test. So next for the flexural strength test. For the flexural strength test, according to the above result, the concrete prism dropped when the partial replacement of cement with Kenaf core was added. But for the 28 days, it showed an increasing for the flexural strength at 15% of Kenaf core. The flexural strength could be affected by the bonding of the material of the concrete prism if there were not enough bonding strength. For 7 days, the flexural strength of control sample is 5.73 Newton millimeter squared. Meanwhile, the flexural strength result for concrete with 5% Kenaf core are 10.489 Newton millimeter squared, which is the highest for the concrete with Kenaf core. The concrete with 20% of Kenaf core was the lowest flexural strength for 7 days of water curing, which is 0.207 Newton millimeter squared. Then for 28 days, the flexural strength of control sample is 6.78 Newton millimeter squared. Meanwhile, the flexural strength result for 5% are 5.608 Newton millimeter squared. Then for 15%, it shows the result of flexural strength of 3.482 Newton millimeter squared, which is higher than concrete with 10% of Kenaf core. All the ratios have higher flexural strength at 28 days of curing because the sample have gained its maximum strength. The highest flexural strength occur at 28 days is the concrete prism with 0% Kenaf core, that is 6.78 Newton millimeter squared. Same goes to water curing process for 7 days with the flexural strength of 5.73 Newton millimeter squared for the 0% of Kenaf core. So here the comparison for the result of the flexural strength from the 0% of Kenaf core and 5% of Kenaf core. So next for the water absorption. For the water absorption test, there were no data recorded since the lab was closed due to movement control order since the COVID-19 cases was very high at that time. So we could not get to gain the data. So for the conclusion, from the result and discussion, the objective for compressive and flexural strength are achieved. Only for the water absorption did not get the data. So the conclusion that may be expressed from the research are concrete with 0% of cement replacement has the higher compressive strength, which is 35.30 Newton millimeter squared at 28 days and 24.83 Newton millimeter squared for 7 days of water curing. Flexural strength of the concrete with 0% of Kenaf core for 28 days shows the highest, which is 6.78 Newton millimeter squared. Even the strength is decreasing with the Kenaf core, but for the 15% of Kenaf core higher than 10% at the flexural strength. Kenaf core in concrete as cement replacement has gradually decreased the compressive flexural strength after 7 and 28 days of water curing. This concludes that Kenaf core is not suitable as partial cement. So for the recommendation, firstly is reduce the Kenaf core percentage to below 5% to investigate the influence of Kenaf core to the concrete as partial cement replacement. Number 2 is additional research on concrete properties with respect to resistance to porosity and weather resistance. Use the specific, fine, and coarse aggregate size for all specimens such as spacing 4.75 mm or below than that. Next is try to replace Kenaf core with other waste materials such as shredded paper and plastic waste. And lastly, take and record the sample dimension since not all samples are consistent in size. So that's all from me. Thank you and Assalamualaikum.